So while I'm trying to set up my PowerPoint, Cowboy, what do you understand by programming? Let's start with that. Sorry, please, I'm going to make this class. I want to make this class interactive. So feel free, even if you're not sure of what you want to say, just say whatever you understand. If you're wrong, I'll correct you. If you're right, I will applaud you. So
I
what
don't
do you
know.
understand by programming?
I'm a novice, so I'm trying to learn as much as I can.
Sorry?
I'm a novice in this area, so I'm trying to learn anything that I can learn right now.
Oh, okay. Okay. Who wants to help us? Like programming, what do you understand by programming? Or program? Like what's a program? What's a computer program?
I would say I would take a jam at it, a stab at it. By program, I understand by program the language of, let's say, computer. Just like when you get to like a different, let's say, country, people have different languages. So before you can understand or talk to someone, you have to understand the language. So basically, that is the language for is like something for computers. You know, computers always understand binaries. So for them to understand, you have to speak the language. So programming to me is something that is used for computer for them to, to tell them to execute something, to run, query, to run pretty much anything. So you have to run a program.
Yeah, you're actually on the right track. You're right. So just I don't have this in my slide, but because of people that are very new, so that's why I'm trying to start from here. So a computer programming basically is a set of instructions given to a computer to do certain tasks, to do a specific task, to do some tasks for you, basically. Like a set of instructions. I think that's the keyword. Set of instructions. And you can see it as right now, as I'm trying to control my system now, I'm using a mouse. This same thing that I'm doing, I can do it programmatically. I can write a computer program to do some of this controlling that I'm trying to do. So take that as program. Program is just a set of instructions given to the computer to perform some task. Then we also, if you don't want to call it a computer program, you can also just, sometimes not even sometimes, most times we just shorten it to the program as a computer program. So it's a set of instructions you are given to your computer to perform some tasks for you. Then now comes in what we call a programming language. Of course, if you're going to communicate with the computer, there's a need for a language, right? If you want to give an instruction to the computer, there's a need for a language. So that's where the programming languages come into play. And before that, let me also make this clear. Software, we all know what a software is, right? Like your WhatsApp is a software. Your things that are not, things that are not the non-physical component of your computer. Like WhatsApp, for instance, is a software. You have even your Windows operating system is a software. Most of the applications you are using, they are softwares. So they are like how do I put this now? Softwares are like combinations of programs, different programs. Softwares are made up of programs, like series of instructions. So try and understand that softwares are series of instructions. They are made up of series of instructions. Like your WhatsApp now is just like so many instructions that are given to your computer and is able to come up with interfaces, and even when you send your message, is able to relay your message to another person on another system. Or they are all just instructions that has been I don't want to use the word compile now, but that has been made into something like a unit that has been made into a unit. Is that clear? Is anybody confused before I move on?
Yes.
Series of instructions.
Okay, you want to ask a question? Sorry. Hello. I'm coming. Sorry, please. I'm not able to multitask. Okay. Professional screen. I'm coming, please.
Okay.
Let me stop sharing and just come here. Oh, let me also start recording. Let me start recording.
I'm recording already.
Oh, okay, awesome. Thank you, sir. Thank you.
You're welcome, sir.
Sorry, please. Primary monitor. Okay. Okay. Okay, I think it's good now. You can see my screen, right?
Yes, we can.
Okay,
Yes, we
awesome.
can.
Yeah, all right. So I think I stopped at programming languages. So I said if you need to, when we said a program is a set of instructions given to your computer, I mean, that would make you to ask a question that, okay, where's the, I mean, like if you're going to communicate with the computer, that mean, if you're giving it a set of instructions, that means you need a language, right? And I said that's where the programming language comes in. And we kind of, we have a lot of them. Basically, we have a lot of them. And fortunately, the ones that we have now, most of them that we have now, they are very close to human readable language. They are very close to the, I mean, English language, basically. They're very close to English language. And they have a term they call, I mean, they have a term for them called, they call them high-level programming languages. High level because they are very close to human language. Basically, when you're writing when you are programming in all these languages, you are writing English. You're not writing any other language. You are using English words to write most of your programs. So they call them high-level programming language. In case you come across anything, they're saying, what are the high-level programming languages that we have? You can mention Python to them. And the reason why they are called high-level is because they are close to human readable language. So programming languages are just the language that you can now use to pass the instruction you want to your computer to give it, I mean, to pass your instruction to your computer. And Python is one of those languages that give us that medium, that give us that privilege to control our system to set some instructions to our computer. And the reason why we are actually talking about Python here and why we are not picking other languages is because it's like the hottest guy in town right now. Like the hottest programming language out there. When you're talking about AI, it has a very large, community and a very large community that keeps on working on it and making sure it is very relevant for anything you want to do right now. So that's why we're talking about Python. And in the last class, we installed it. And one thing I didn't tell us when we installed it last time was when you install your Python, some things came with it. Let me stop sharing and you just permit me to like share on my screen. So we are going to get our hands dirty right now. Oh. So if you have like a 2-screen or something, you can also just practice along. Coming. I'm trying to. Sorry, please. My screen is okay. Yeah. Okay. All right. So the last time that when we install Python, when you install Python, some things came with it. Like there's a basic IDE or something, a basic code editor that comes with it, and it is, if you check your system, you see it is IDLE, yeah. It is like an editor where you can write your code that comes naturally with Python by default when you install it. So sometimes you may not even need the Visual Studio Code, but I'll tell you why we need the Visual Studio Code. Why the Visual Studio Code is more superior to this IDE, this basic editor that came with Python itself. And if you open it, yeah, something like this too, will come up. This is also another proof that your Python has been installed, basically, if you want to take it that way. So once you open the IDE, ideally, this thing comes up, and it is called the Python shell. It is called the Python shell. So this right now, anything we type here now, if you want to, if you want to give your computer any instruction, you can type it into this space here, this space that you have here. And these three greater than signs, we call them prompts. Hope I'm not rushing. Please let's respond if you're
So far so good for me.
okay. All right. So this three greater, whenever you see these three greater than signs, whenever you see them, it means prompts. We call them prompts. These where we are currently, the environment where we are is called Python shell. And I'll tell you why it is called Python shell. One of the commands in Python, one of the commands you can write in Python is print.
Print, okay.
Yeah, it's print. One of it is print. Let me print my name. And if I do this, you see, there's an output here. The command is for what this print does. I'll explain what print does. But now this is our first program in Python, actually. If you haven't tried it, you can open this and just try this, and that will be your first Python program. So we call this Python shell because you see now, after I've written a command, this is a command that I'm saying it should, I'm asking it to print out Gideon for me, and it has printed it out. And if you see again, this prompt has come up again. These three greater than signs has come up again, which is telling you that I'm expecting more command. So this kind of environment, when you have an environment like this, it is called the Python shell. You're in the Python shell. So please take note of this because I'll try and recreate it in another environment in our Visual Studio Code, and you tell me what the environment we are in by that time. So this is called this is called the Python shell, and the three greater than signs are called prompts, which is where whenever you see that three greater than signs and you have your this thing blinking, your cursor blinking, it's saying I'm expecting some commands. Tell me some commands. Another command could be we can even do some basic this thing. You can ask your computer to do multiplication, addition for you. 100 plus 500. And the way after I've typed this, you press enter on your keyboard. That's how you tell Python interpreter to, okay, now take this command and give me the output. So once I press enter on my keyboard now, you see, it's giving me the result 600. So now what we're even using we are now using our computer as a calculator now. When I enter this 100 plus 500 now, what I'm asking the computer to do is to do some calculations for me. And it understands that it understands the plus sign, the plus symbol. Yeah, it understands it as an addition sign, as an addition symbol rather. Yeah. So, but all these, if you have to write your command and all your programs, your instruction, if you have to write them like this, it doesn't really make sense. Or I would say, there's no way you have to, start writing one by one, start writing commands one by one. It would be impossible to even have like the kind of software that we have today, like WhatsApp, for instance. You won't be able to like develop bigger projects or write. It doesn't even make sense if you have to retype if you have to always type out your command all the time. So the way to handle that, the way to take it to another level is to create a file, a Python file itself, where you write your commands, and anytime you need to tell the computer to do them, you just go and run that file. We call it run. Or another, you can just have to like tell the computer to work on, to take the instruction. Hope I'm not confusing anybody, please. I said, with this, it's the advantage of having a programming language is such that you can have, you can write as many programs, as many instructions. You can give as many instructions to your computer. And the next time let's say you need it now, you write those instructions. The next time you need them, you don't need to write them again, come into your Python shell and start writing them one by one again. So you can just write your program once and for all, save it in a file, save it somewhere, and anytime you need to give that instruction to the computer, you just say, okay, run this particular file. So, and that is the ideal way to program. Most of the time, when you come to this Python shell, you just use it to do what we call debugging, just to test things out. Like for instance, if you want to test out, like there's another command in Python called what was it called? Which one can we do now? Inputs, which is how you take inputs. You take a user inputs. I will explain all these things. Why we have all these things, like the syntax, how Python got to, how all these are made up. So let's say I want to try out this one now. You can use this kind of Python shell to try out. If you're not sure of how a program will work, you can just come to the Python shell and just try to test things out there. This one, enter your name. If I do this, you see, it says enter your name, and my cursor is blinking. And of course, you expected that before now, when I say print Gideon, Gideon was printed, and the prompt showed up again saying, I'm expecting more Python command. But in this case, I entered input, enter your name, which is a Python command, an instruction I'm giving to Python to give to my computer. And the next line, it says, enter your name. The 3 prompt is no longer showing, which means the code, this particular command is not done executing. But what this input does is it asks user for input. It's asking me for something. So then I can enter anything there. I can now say, enter your name. My name is another of my name is Daily. And when I enter Daily, you see, Daily got printed. And you can see the prompt now telling me to now enter another part. That means this particular command or instruction is done executing. The computer is done executing that command. Now it's expecting me to enter another command in Python language. But I said all this is just for testing. You only use this kind of Python shell for testing. Ideally, if you want to write your program, the standard way is to, whatever code editor you are using, you go to File, click on New File, and you write your, let's get familiar with the print statement now. I'm printing my name. Let's say this is the command I want to save. I want to always, give to my computer to execute maybe later in the future. After you've written your command, you save it. You go to File again, and you click on Save. So ideally, I tell people that whenever you're working on a project, it's just like, for instance, we have this class now. You can create a folder on your system. You can create a folder on your system and name it the name of this cohort or anything. Make sure whenever you're saving, make sure you save it in you structure your project, or you structure your system generally. Don't just litter files around on your system. If you have videos on your system, put them in a separate folder. If you have Word documents, put them in separate folder. And most especially for your programming projects, make sure you have a separate folder somewhere okay, if I need to, my Python project, this is where I'm saving them. So for this particular cohort, I'll be creating a folder here in my documents. You see, I already have a lot of folders for some of the projects I've done in the past. So I can create a folder, and I'll call it, are we in Summer now? Yeah, Summer Python class. And inside it is where I will save my file. The command that I've written, the Python command that I've written, I want to save it now. And I'll call it first code. So there's one thing you need to take note of. Whenever you're saving your Python file, for your computer or for even for Python interpreter to know that this is a Python file, that is, in this file you have Python commands, Python instructions, it must end with that file must end with an extension or a format. I think it's called extension, yeah. That file must end with an extension called .py. the name I'm giving to the file is first code, but the extension, I don't need to break it down again. Extension is like, is always unique for a file format. Like for instance, now if you are used with Excel data is mostly in .xlxs or .csv. That's how Excel recognizes its file. But in this case, the way Python recognizes its file, that is where you have your Python command, the way Python interpreter or your computer even recognizes it is when it ends with .py. Yeah. So now I'm saving my own file as firstcode.py. And once I save it, the command has been saved. And if I need to run it, now you see the run command there. Come to this run command. If you are, this particular approach is, the way I'm running it and the way I'm saving it is only peculiar to this particular code editor. When we get to Visual Studio Code, you see the interface is quite different, but it still works the same way. You still have your save option, your run, even your run option. In this case, on Visual Studio Code, you will not see the run. This is coming as a menu, but on Visual Studio Code, it comes like a button. So we'll get there. But when you're using your IDLE, after you've saved your file, you've written your commands. If you want to run it, you click on the run menu here, and you click on run module. So once you see, it will bring us back to the Python shell. And now this is the beginning of the program. It's saying it printed out Gideon. You can see. Gideon has been printed out, which is coming out right now. I didn't have to type it out I didn't have to write it on the Python shell itself. I had written it in a file. I run the file and the output showed in the Python shell. So that's just how you come up with your programs. Now, let me explain this command that I've written here. One of the Python, we have so many, the reason why people say Python is hard is some people think maybe there are certain words, just like in English now, there are some words that are valid in English and there are some words that are not valid in English. You all agree with me, right?
Yes.
Same way in Python. There are some words that are valid. There are some words that are not valid as a command. If you're talking linguistic now, that we have syntax rule, and even in English, we have syntax rule and semantic rule and the likes. So there are like syntactical structure to Python commands as well. There are ways you write Python commands that are acceptable, that Python will recognize that, okay, this is the command for me. You are telling me to do this. So those are the things you need to pay attention to and really learn. And the way you learn them is when you practice. You don't need to cram anything. You don't need to cram, trust me. If you cram, you forget. The best way, just like every other field, even our day-to-day life, the best way to master things is to practice. The more you practice, the more they get registered into your memory. So let me explain this. Print is one of the commands in Python, one of the keywords. We call them keywords. So it's one of the keywords in Python, and it's a function. We call it a function. I will explain what the function is. But what this one does, the task it does is to output something to the user. You are the user. So what this print does is it is the Python command that gives you anything you pass into it, is going to output it to you, is going to give it back to you. Now I'm saying what I'm literally saying when I wrote print open parentheses Gideon in quotes, make sure it is in quotes. I'll tell you the reason. Later on, we'll get to know why it has to be in quotes. But what I'm saying is print out Gideon for me. And that is what it has done on the Python shell. It is printing out Gideon. I can even add more command. I can say print out. Let me print someone else's name. I want to print Kabwe. Sorry. Let me print out someone else's name. Let me print Nadia also. After I've written the command, I saved. I press Ctrl+S on my keyboard. So just to save things, but then you could still come here and just do your save. Just like you're using your Word document. You save so that when you come back to the file, you still meet it where you still, have it at the point you left it. So after this now, let me run it again. And you see, now on our Python shell, you can see we have Gideon, Kabwe, Nadia. So what the print statement, the print command here does is whatever you give to it, is going to output it to you. It's going to print it out to you as a user to see. So that's just what it does. Now let's go back to
Hello.
Do you have any question before we go back to the slide?
Yes, I have a question. So within Python, would they use classes? Would they use classes?
Classes in what sense? Sorry.
For example, in Java, there's classes and classes within
Oh,
Java. Is it the same way in Python or?
yeah, Python is an object-oriented programming language. Is an object-oriented programming language, but unlike Java, in Java, sorry, please, this may be a bit above the class, but I think the person asking the question is a bit, is an experienced person. So in Java, you have to create like a public static class. Yeah, like a main this thing before you can, whatever you put in that main, what's it called? Is it function now? Method.
Function, yeah,
Is what the interpreter run or the compiler compiles rather.
Mhm.
I don't know if I'm in Java. But in Python, what makes Python the easiest programming language is you don't have to consider all these things. Python is also called a procedural language. In the sense that you see the way I'm writing, most of the programming languages that we have out there, trust me, this way will not work. If you have to, this ordinary print statement that I'm writing, in some other programming languages, it will take you have to write 5 lines of code before you can get this kind of output. So just back to your question, to do most of these things, you don't necessarily need to even define class to have your Python program, to have a very robust program. You don't need to put it in class, but for modularity's sake, if you want to follow the best practices and the likes, if you're writing a big program, then it's best that you write it in classes, just to make it modular to follow the best practice. Is that clear, sir?
Yes, it is. Thank you, Phil.
Yeah, you're welcome. So now, I won't advise you use this ideally as your editor. Remember when I was introducing it, I said it's a basic editor in the sense that it's very crude. It doesn't come with some features that will make your programming life easier. And that was why I recommended we download Visual Studio Code the other day. So with Visual Studio Code, let me close this, but then I've saved the file so I can always open it back in Visual Studio Code. Let me close this. And yeah, I'm having to share my screen, so no problem. Okay. So let me close this. So once you open your Visual Studio Code, it's just it's very similar to your IDLE that I just closed, but there are some more features to it. There are more buttons in a way. But one thing is, if you have your Visual Studio Code, it was just the same way as our IDLE. If you want to create a Python file, you can just click on new file here, or you can even open into a folder. Let's say you've created your working directory. That is where you want to be putting your Python files. You can open it. Let me, I created one in document, right? And I have it in, can someone remind me the name?
Python.
First code, something like first code. You created a folder called summer
Okay, summer. Yeah,
class,
exactly.
summer Python class. Yes.
Yeah, exactly. So I want to open I want to open this folder, this summer Python class. I want to open it into VS Code so that I can always access, if there are many, I can always access everything in that file easily. So I'm opening into that folder, and if you see, this is just like this is saying, do I trust the source? Always click on I trust it, so far it's your system. So now you can see I opened into that folder, and on the left side here, this is where we call the Explorer. This is the Explorer side, Explorer part. So you have some buttons here, you have some features here. I'll tell you the important ones there. But the first one here is the Explorer. which opens to your working directory. Wherever you have your file, wherever you open to, like let's say you open into a folder now, everything in that folder will appear on this part. So it kind of mimics your normal system file explorer. If I open into this folder now, trust me, I'll see everything that I have here. I'll see it on the file explorer, and then I can open to them and interact with them, open them into the Visual Studio Code. Like this one, I have this first underscore code. If you see now .py, there's an icon beside it. That's the Python logo. That's the Python logo. I think I have it on. I'm not sure if I have it on the slide. Okay, but I think you can also see it. This one that where I'm overing my mouse. This is the Python logo. So anywhere you see it, just know that this is the Python logo. And you can see that icon beside your first underscore code.py, which is telling you that, okay, even your Visual Studio Code identify that file as a Python file. And you can just click on it. Once you click on it, it will open on the canvas, like on the editor here. And you can see all the commands we've written in the past. So now, this Visual Studio Code is called an IDE, Integrated Development Environment. And with Visual Studio Code, it's not even limited to Python programming alone. You can write as many other programming languages in Visual Studio Code. So, it's not built specifically for Python. And the reason why we call it an IDE is because it has so many features that will make your life easier. Like for instance, you can even, if you forgot, like, let's say you are not sure of a particular command, this Visual Studio Code, you can install, or you can make it in a way, you can set it in a way that it will correct you when you are wrong. Let me do something now. The same print statement, let's say I write pw print and I'm saying Gideon. You see, it has it underlined, telling me that there's an error. And if you hover your mouse on it, you see, say, point is not defined, saying it's not defined. And once I know that there's an error, my attention would, because I'm experienced in a way, so I know that, oh, there's nothing like point, it should be print. Then I can easily correct it. Something that wasn't possible with IDLE, the one that I was using before now. So that's why it is recommended that you use IDEs. You have a lot of them. We have another one called PyCharm that is built specifically for Python. So that's why it is advisable to use them for your programming, for writing your codes, and so on. Let me include another one. Let me include Jane here. And now let me save it. So I've saved it. And now, instead of, you see, you have the run menu here. And I've never even tried running from here before. But one thing is, I can, if you want to run this particular script, you can see the play button here, which when you put your mouse on, when you hover your mouse on, it says run Python file. So you can click on it and the terminal, like this terminal here, will show up and you will see your output there. Any question? Nadia, are you getting me?
Yes.
Any question here, or do you have any doubts, anything?
Wow, I'm getting it.
Okay, and
Thank you.
somebody also said it was new. I think Fabrice, right? Any question?
Let me mute myself. Can you hear me? Hold on. Yeah.
Yes, I can hear you.
No question. No question. I'm good. As you are running the code or typing, I'm trying to mimic that here also on my thing.
Okay.
So I'm good. I'll try to follow.
All right. So, like I said, print statement, I want you to get familiar with, get yourself acquainted with this print statement. It's one of the keywords in Python. We have so many of them. And trust me, you don't need to know all of them, but just try and make sure you've used them probably in the somehow you've used them. And I never had to memorize all these things. I just make sure I practice. I learn from videos I'm reading tests, then I practice. And later in the future, whenever I'm building anything and I need to do something, it just comes to me naturally that, okay, this is the keyword to use in this case. And trust me, as you follow with this class and you also practice and I give you some assignment and you do them, it will also come naturally to you to become part of you. So That is that about the print statement. And also in this same folder, I can create another file. Now, using Visual Studio Code, you have so many buttons there. You have some, everything has become so easy. You can click on this new file here. And let's call it second module. So just one thing to take note, each Python file like this, each .py file is called a module. Take note of it, please. It's called a module. So then .py, remember I said, always remember to put the .py extension. That is how your system generally understands it is a Python file. So now I've created another file and I can even say print 200 divided by let me just do addition. Let's say subtracted, 200 minus 100. So then I will have to save. So if I run this, what will be the outputs? Let me call someone. Danny, sorry. Danny, what's going to be the output if I run this?
The output is going to be the remainder of the equation. So 100 is what's going to be given.
Okay, yeah. So if I click on this run Python file, you can see 100. And let me minimize this. If you can see from the terminal here, where you are seeing our output, you can see it's telling us that this is the part, this is the file that is being run, that Python is running basically. You can see second module.py. So luckily or fortunately rather, when you are in the file that you have opened, when you click run is the file that gets run. I don't know if that makes sense. Now I'm in second module. That's why the second module is running. If I can be in second module and click on this play now, and first code is going to run. No. Except if you want to select it here and say run Python. I think there's a way you can select a particular file, something from here. But it's just like the ideal thing is whatever file you want to run, make sure you have it open in your editor. You have your cursor there before you click on the play. Before you click on this run button and you see your output. Let me run first code now. And you can see your outputs there. So I said a print statement is a function, it's one of the keywords in Python that is used to output whatever you give to it. And even not those just one word thing, you can have my name is Ellen. So it's not just one thing, it can be anything you put inside it, but not still just anything like that. I will explain like the same what's the rule behind it, things that you can put inside basically. But you can just, if you want to output anything, make sure you put it in these quotes. Make sure you have it in these quotes. After the parentheses, the opening and the closing parentheses, make sure whatever you want to output is in these quotes. For now, take it as that. Make sure everything is in that quote and you won't have any issue. If I don't have a quote there, it will raise an error for me. You see, it's already underlined, but even if I run it here, it will, you see, there's no output. It only says, what was it called? Syntax error. Unterminated string literal detected at. So if you're not following the right syntax, the way Python wants things to be done, there's going to be error. You won't have any output, you won't have a result. So, and with this foundation that we are going to be doing for the next 5 weeks or so, you'll be learning about the syntax, how you can write in such a way that Python understands and you won't have any issue. So let's go back to the slide.
Sure, Danny has a question.
Okay, all right, please go ahead.
Getting back to the VS Code that I was wondering if there were any extensions that you would recommend that could facilitate writing syntaxes, whether it be for Python or other programs like SQL. Are there any extensions you'd recommend or that you have downloaded on your own VS Code?
Thank you so much. I wanted to say that. So for some of you, you may not have your Visual Studio Code may not be on underlining or be dictating error for you. because you have forgotten, I actually have more remember I told you Visual Studio Code is not made specifically for Python. It is made for a lot of programming languages. So here now, for it to recognize most of your, for it to work with your Python programming seamlessly, you may have to install some extensions. And the most important one is, if you want to install extensions, this is the tab for it. Sorry. Yeah, this is the tab for it rather. The first one you have here is for the Explorer. Then when you come down here, this one is where you have, where you can download your extensions. So extensions are basically what, add more functionalities to your Visual Studio Code. And in this case, we want a functionality that will help us write Python program easily and, gracefully. So one is, if you can just type out Python. Once you type Python to the search bar, you see this Python here, this one here. Yeah, just try and install it. I already have it installed, so I don't want to disable it. Just install it, download and install. I think it will do that. So I think automatically it will download Pylance for you. And Pylance is, I think, what does the error detection for you, the underlining and the likes. So once you download this, it automatically, I think, add others. But if it doesn't add others, just download this Pylance as well. Say Python debugger, Python, and Pylance. And based on, if you're working on some other project, like for me, I work with Django. So I have these, there's something we call Ginger in Python also, or in software engineering, development rather. So you can also download this Django, but you don't need it for now. And like he said, if you also, if you want your Visual Studio Code to work with SQL, you have so many extensions there that you can use. But I've never really had to use any. For if I need to work with SQL, I don't write SQL in my Visual Studio Code, so I don't know which one to, but you can go online and search for anyone that may be needed. Is that clear, sir? Sorry.
Yes, that's perfect. Thank you very much.
All right.
Okay, I have a
So
question,
please,
Mr. Gideon, before you move on, please.
all right.
On your second, I know you just emphasized the importance of the quotations, okay?
Okay.
But I have seen that on your second module, okay? Let's go back to your second module. Okay,
Yeah.
you see in here, 200 minus 100, it wasn't in quotation. And everything prior to that in your first code, everything is under quotation, but this one, it ran without a problem. Is there a difference between numbers and letters, or
Yeah.
why?
There's a difference. There's a huge difference. There's a
Okay.
difference. Let me just say it that way. So, and I'm going to explain that. But please, I really commend you for this. I actually thought someone was going to ask that.
Okay.
It's good that you pointed that out. So there's a reason why I don't have this in quotes. And though I will explain for better later on when we're talking about data types, but the main reason is because of data type, basically. You agree with me, even in the real world, or in our, in the real world, basically, numbers are different from letters.
Okay.
There are things you can do with, you cannot say A times B. Let's say in algebra. Is anybody asking something? Oh, okay. Let's say in algebra and mathematics now, you can do A times B, but then in the real world, there's not, A times B doesn't make sense. You can only say a number multiplied by another number. So in programming, it has Python also has a way of handling that. What we have here is they are called strings. We call them strings.
Okay.
Like they are just something you can liken them to the real world alphabet. Non-numbers. You can liken them to non-numbers. Whenever you want to output anything that doesn't have to do with that is not mathematical in a way. Sorry, my accent is so if you want to print out anything
Trust me, we all have accent. Trust me.
Okay, all right.
As long as I can understand you, you're fine. Don't worry about your accent.
If you want to print out anything that is not mathematical, when it's not like you're trying to compute anything mathematical, you have to put them in quotes.
Okay, makes
Let me
sense.
give you that theory. You have to put them in quotes. But when it is mathematical, when you feel like, okay, that particular thing has to retain its mathematical value. Then you don't have to put them in quotes.
Okay. And if you do, is it going to give an error or not? By just to know.
If I do that, now it is going to take this as string.
Okay.
It is not going to do any computation on it.
Can
you guess what the output to be?
Yes, it's not going to do the computation just like you said. It's going to print 200 minus 100. That's it.
200 minus 100.
Okay,
which you
it's
can
not
see.
going to do the computation. I get it now. Okay.
Yeah,
Thank
it's
you,
not
sir.
going to do. Yeah, you're welcome. You're welcome.
Yeah.
So please, if you're confused there, don't worry. I still have it.
Would that in Python, would that still can be considered an integer?
What did you say? Sorry, can you?
I said in Python, would that also be considered an integer?
The output, right?
Yeah.
The output is not an integer.
No, not the output, but I'm talking about I'm trying to differentiate it from Java. In Java, it would be integer quotation.
Yeah. In Python, it's also integer. It's also an integer.
It's also integer. Okay.
Yeah, it's also an integer. We'll get there actually. Let me just quickly come back to this slide. You can see this, right? Sorry, please. My screen will be a bit messed up, but you can see my slide, right?
Yeah.
Okay. So let's just do it for hopefully before the next class, I would have gotten the second monitor working. So today I think I already did justice to introduction to Python. So we'll also be talking about numbers and operators, which will shed more light on why we have some things in quotes and we don't have others in quotes. And also we're talking about data types basically. And I wanted to take note of some of the key features in Python. Like I said, it is very easy to code. And even take it from me, I feel like for someone I've had experience writing C++ and C++ for embedded systems, and I've had experience writing Java. I can tell you Python is the easiest I've laid my hands on. Like very, very easy. Very, very easy. So, and it is free and open source. Just like it is publicly available to anybody. You don't need to pay. It's not owned by any private organization. The community manages it. The community of developers around the world manage Python. So like you see people keep working every day to make sure it is up to date, and Python can do a lot of things. Trust me. Gaming, they use it in gaming, in web development, in embedded systems. That is all these IoT, Internet of Things, robotics, in programming robotics. They use it in a lot. So, and also object-oriented language is this object-oriented language is just is a paradigm in programming in a way that it's something in a way that, it's a concept that allows us to program in a way that we can model real life scenarios. Yeah. So there's a specific distance for that. Like it's going to be like a whole distance on its own. But just take this property of Python. We have so many object-oriented languages. Like Java is an object-oriented programming, C++. Most of the modern languages are object-oriented. And when we are talking about object-oriented language, what we are just saying is that they have this ability, or they allow us to program modeling real world. Like if you want to model real world now, say the way you interact with people and all, you can program it you can write it in Python. Python allows you to, there's a way you can model real life scenarios and it will make sense programmatically. When we get there, you see the demonstration, but that's not like what we have to focus on right now. It's an advanced topic, and just know that Python is an object-oriented programming language. In case someone just asks you, it's a general knowledge. It's something like it's a general thing everybody should know. And remember, I explained this the other time, why it is called high-level language. You can see print is an English word. I'm not speaking anywhere. We're basically writing English words. We just need to write them in certain ways. Certain ways. That's how the little difference between them and English. So the fact that they are very close to human language, to what we speak, makes Python one of the high-level languages we have. An extensible feature is just that it works well with some other programming languages like C++. So that's like the advanced part of it. and it's portable. It can work on any system, both Mac, Unix, and any operating system, basically. And it's an interpreted language. It is executed line by line. You did not ask me this the other time, but if you noticed, when we run this, you don't find my name is Ellen. You don't find it appearing first before print Gideon. Let me run this again. You see, we have print Gideon, and the first line of code here, we have Gideon. The second line, we have Kabwe. You have Kabwe here. Nadia, we have Nadia. So Python runs Python interprets this command line by line. From top to bottom, basically. Let me just take it. It runs them from top to bottom. So Python interpreter starts from the very first line and goes to the bottom, and goes down, to be interpreting your commands. So the first thing the interpreter sees is this line, print Gideon. Then that's why you see it's printing Gideon first, then Kabwe printing this thing first. If I bring this print, my name is Ellen. If I bring it to the top, this is going to be the first thing that Python is going to, run now. You see, we have my name is Ellen, followed by Gideon, Kabwe, Nadia. So when Python is interpreting your code, it runs it from top to bottom. And as an interpreted language, you appreciate that property more if you're coming from, if you're writing other programming languages like Java. Like we say, Java is a compiled language. Compiled in the sense that it's, no, let me not bore you with this. But I think one thing you can just take away from that property is that Python runs your code from top to bottom. From top to bottom. Let's take it like that. And also dynamically typed language. You also appreciate this if you're coming from another programming language angle. Like in Java, for instance, if you need to define a data type, you have to specify the name there. Like if you're defining an integer, you have to put the int keyword there to say, let's say this is a var, and you call it, let's say 4, something like that. But in Python, no. Python detects the data type by itself.
Yeah, that is what I was trying to ask. Would you have to define an integer before you?
No, you don't have to do that in Python. So that makes Python a dynamically typed language. When you are defining your value or your variables, you don't need to specify the data type. Python determines the data type during runtime. When it is running the command, that is when Python determines what data type is right for that thing you specified. So that is that about the features of Python. Any question before we move on?
I have
Okay,
a
yeah.
question.
Okay.
To use this app, do you have to have a file from, because can you start a new file from, can you start coding from here right away, or you have to use a file from, because I know you use the older file to start from here. So can you start from scratch using this app, the Visual?
The Visual Studio Code?
Yes.
Okay, you mean, can I start? Yeah, you can. You can start from scratch. Okay, I opened into an existing file. If I want to open a new file, into an existing, if I want to, create a new folder and everything, I can click on open folder here. Let me create a new, or even let me do that outside the platform itself. Let me come to this and let me create a new file and call it, what was it called? What did I name the folder? Summer 2. Summer Python class 2. I can do it from the platform too, but then I just want to create it outside the.
So that means you have to create a file before you start.
I'm
You
not
have
creating
to,
a file in this case. I'm
okay.
creating a folder.
Yeah, you have to create a folder before you start, right?
Yeah, you can do that, and you can choose to do it on the. I've deleted it now. You can choose to do it also from here.
Okay.
Hope I'm not confusing. You see, I said, remember what I said? I said it is not actually compulsory that you create a folder before you can create your Python file. But it is just like the best practice to always have your file structured, properly structured. You don't want to litter your file around.
Okay.
Yeah. So I can do that. Let me just create that folder from here. I can easily just, go to open into a folder. Let's say my document folder now. I can just open into it. Save the changes to, save this before. So I can open into it and you can see all the files. So I can create a file into my document folder. I can create a new file into my document folder and name it anything .py, gfd.py. What's going on? Okay. .py. I can create the file. But I mean, I have a lot of things here. So it will be very hard. Let's say I want to like locate the file now. If it's not that I have a very sharp memory, it will be very hard for me to locate. So that's why I always recommend that you create a folder for your somewhere you can, you know that, okay, this is the only thing I have in that particular.
Okay.
Yeah. So now let me go back to, let me even open into a folder, my Word document now. Let me create a new folder and call it Summer Python class 2. So I've created the folder, I've clicked on it, then I can select the folder to be opened here. And see, once that folder is open, the file explorer is showing the folder. Nothing is there currently. I
Yeah.
can come here to now create the file. You see, new file, not new test file.
Okay.
Yeah, test file is going to create a .txt file for you,
Okay.
like just a normal test file. But because the extension for Python file is different, so it's going to be new file. I can do that from there, but I mean, we have a button that does that that can easily do that for us. So just click on this plus. This, if you want to create a new folder, this is even where you can do it. Let me even create a new folder now and call it source, SRC. Inside my Summer Python class 2, I'm creating another folder called source. And you see the way I've created it.
Yeah.
This but a new folder here. So inside it now, I want to create my file itself. Then let me call it, I've clicked on it. Then I can now click on this plus. Or when I click on it, I can right click on it, and after selecting, I can right click and click on new file. It will be created inside the source. Let me call this main.py, and I press enter. You see, it has been created inside SRC. Does that answer your question? Hello?
Yes. Thank you.
Okay. Yeah, you're welcome. Please don't hesitate to ask any question. There's no stupid question. Ask anything.
Okay. Thank
Yeah, you're welcome. Yeah, we've talked about the key features. And yeah, also now that takes us to, I think you already know what print does. So there's something we'll call, not just in Python, in programming generally, there's something what we call function. And just like, and so one thing that I should also, point out to you is in programming, most of the word we use actually, they are, they are words from our day-to-day activities, like they are normal English words. So whenever we talk about a word, you can first try to understand it from the vocabulary point of view, like try to understand what it means, in English itself. And now try to maybe shift it into the programming world, and the difference is not always that far. Like for instance, when we talk about function in English, function is, when you hear about function, it means like it's very close to like duty, right? I mean, there can be different meanings to function though. Functions like a ceremony can also be called function, I think. So, but function in, say the first meaning in a way, is going to, when you talk about it, like when you say you have a function, that means you have like a role, you have something you are doing, like a task a role you are occupying, something you are doing that is assigned to you. So same way in programming, we have some things we call function. and they are reusable piece of code. Reusable piece of code that completes a specific task. Now, reusable piece of code, because they are codes. When you install Python, when we install Python, the Python installer that we downloaded online, when we install it, some codes came with it. Yeah, when you are installing some codes that has been written by, I said, a community of developers, they manage Python, right? So when you install Python, many Python files that has been written comes with it. So even the print statement we are using is part of those files. It's a code that has been written. So that's why we call them functions, a reusable piece of code. It's a piece of code that has been written that we can reuse anytime, that complete a specific task. Now, for the complete a specific task, like I said the other time that the print keyword, the print function, it's a function. Its own purpose, the main purpose, what it does is whatever you pass into it, whatever you give it, it will output it to you. That is the task that the print function is doing. And how do you recognize a function? One thing you will always see a lot in Python is when you write some words and you see open brackets. I think the right thing is parentheses. You see them after you write a word, you see a lot of things enclosed in open and closed parentheses, like we have them here. This and this. Sorry. I don't know if you can follow my mouse. Like you see after you write the function name, the name of that function, you always see them at the end. You always see open and close bracket like this. That's how you identify a function in Python. If I write anything and at the end I put open and close bracket like this, just know it's a function. It's a piece of code, a reusable piece of code that is meant to perform a specific task. So, for instance, again, the print function is used to output a message to the programmer, just like we've been using it. Anything you pass into it is going to give it back to you. It's going to output it to you, show it to you. That is that. There are so many of them, and we'll get to use them even in this session. And you can change the data given to the function to change the outputs. Just like, we're able to print Gideon, and in another print command, we're able to print Nadia, we're able to print Jane, and so many. We're able to print my name is. So depending on you can change the input. What you have inside the parentheses is the input. So you can change them, and when you change them, they actually affect how they change the output also. It affects the output. Like in the print statement, now if I put Gideon is going to be outputted to me. If I put Ellen is going to be outputted to me. So that's what this point is saying, that you can change the data given to the function to change the output. So, and yeah, let's try and do some other. Okay, I think I already explained this. I've shown you how to use print statements. Now, this takes us to, we're still going to talk more on function, but there are some things we need to also take note of, which is how Python handles numbers. There are two main representations of numbers in Python. In mathematics, you have decimal point numbers, right? And you have whole numbers. So we have that category also in Python. Python also has representation for those two categories. Whole numbers are represented with integers. They are called, the name of that data, the data type is called an integer. Just like it is in mathematics also. Integers are whole number, either positive or negative. I think they are real numbers also. Yeah, I think in mathematics, they are called real numbers. Or something like that. But then when you have a whole number, something with no decimal points, either positive or negative, either you have minus there or there's no minus, which is positive, right? So they are called integers in Python. This knowledge is very important on how to come up with the right syntax in Python. So take note of them, please. Whole numbers, either positive or negative, they are called integers. And numbers with decimal points, either negative or positive, they are called floats. So those are like the categories of, we have so many categories of data types in Python, but numbers numbers, the way Python, the two representations for numbers in Python is integer and float. The ones with decimal are called floats. The ones without decimal, they are called integers. And operators, the mathematical operators we have in Python, the mathematical operators that we have, the normal addition, subtraction, and multiplication, that are symbols. Like Python uses like the additional plus. Python recognizes the plus symbol as addition, and the hyphen, which is minus, as subtraction. But contrary to how, in mathematics, you use X for multiplication, but it is different in Python. If you want to tell Python to do like a multiplication, we use asterisk, a single asterisk. So let me stop sharing and go back to practicing so that we can get our hands. So what I'm saying is, or let's even go to, let me do this in Python shell. So where am I currently? Can someone tell me what environment I'm in? I'm talking about this environment now. I'm inside my terminal, but I've initiated an environment. And can someone tell me what it is? What environment am I in?
You're not sharing.
I'm not sharing. Oh, sorry. I thought I was. Sorry, please. Let me start again. Okay. So I mean, looking at this terminal, like here now, like where we have. So this terminal is also like very similar to your command prompt. Anything you can do in your command prompt, you can also do in here. So one of the advantages of having Visual Studio Code is that it brings everything into one place for you. Your terminal, your editor and everything, it brings everything into just one place. You don't have to start, go open type your code, then go to the terminal to run it or anything. Everything is in one place. So now back to my question. I've initiated an environment now. What is it called? Based on what I explained earlier in our class, in this session. I'm in an environment now. What is that environment called?
Is that a Python shell?
Python shell, exactly. I am now in a Python shell. And the way I did that is, I just have to, when you write Python, just type Python in your command line and you enter into the Python shell mode. So when I was using IDLE, I'm coming. When I was using IDLE, I didn't have to type Python before this thing showed up because this one came with Python generally. So it's when you open IDLE, it's naturally, it's by default open you to Python shell. Yeah, but because we are using like a third-party editor, if you want to enter into Python shell, just type Python and press enter. It will take you into your terminal. It will take you into the Python shell. So back to our data type thing. 12 is an integer. Minus 99, I said, is an integer. So I can tell Python to print 12 for me. So the way if you want to let Python understand that the number you are giving, let's say you are giving an integer, it's 12 is a whole number is an integer. To let Python know that it's an integer, you don't have to put it in quotes. Just the same way you write it in mathematics, just, give it like that. When you don't put them in quotes, Python takes them as integers and it can do operations that are particular to integers. Like your numeric, what was it called? Your your mathematical operations and calculations, you can do them on them. When Python is able to recognize them that, okay, this is a number. If you want to do multiplication now, you want to do 12 times 2 now. Remember I said we use asterisk instead of x. If you put x, there's going to be an error. So to do multiplication, it is an asterisk. 12 asterisk 2. And if you do print now, sorry, let me quit. To exit this, to leave your Python shell this thing, you just have to write exit, then open and close parentheses. So exit is also like a function, basically. Yeah, so now let me save this and let me run. I'm going to, the response is going to be 24. But if I should put this in quotes, so that was why the other time, I mean, when we don't have them in, when we have them in quotes, it behaves differently. If I have everything in quotes, it's just going to give me everything literally, if that's the right pronunciation. So it's just going to give me everything as it's going to give me this 1, 2, asterisk 2. That's going to be the output, you see. Because we have them in quotes, Python no longer sees them as integer. No longer sees them as things that can, that you can do some mathematical computations in. So now let's do away with this quote. We'll tell you why we have to put some things in quotes later on also. There's another data type in Python called string, which is how Python recognizes text, like non-mathematical data types. So now if I want to do division now, instead of having this, the mathematical symbol of division, that's not allowed there. You don't have that on your system, or it's not even, you don't have it. Python doesn't recognize that. So you use a / for division. Let me come back to Python shell just so I can just do my demonstration. So now I can say 24 / 3. 24 divided by, I'm just saying divide 24 by 4. Sorry, 24 / 4. Divide 24 by 4. And if I press enter, you see the output is 6.0. Can someone tell me the data type of the the data type of the output?
It's a float.
Who doesn't agree? And sorry, I can't see our names now, but let me call some. Nadia, why is it float?
Because it's a decimal, right?
I want Nadia to
Yes.
answer.
Okay, 1 second. I'm thinking.
Okay. Not to waste our time. The reason why it is float,
Because it's a decimal number.
it's a decimal number, exactly.
Yes.
It is float because it's a decimal number. Yeah, and mind you, what we're actually dividing, I put them as integer, like 24 is an integer, 4 is an integer. But when the division has been done on them, the output is given as a float.
And why is that? You couldn't have
That's
said just 6.
that's Python. That's like Python is a modus operandi now. That's how Python works. Whenever you are doing division, it always results in floats.
Got you.
Yeah, when you're doing division, it always results in floats. So let's even do one. Let's do 23 divided by 3. There's going to be a remainder, right? So I think this is the reason why Python just returns everything as a float, just in case you do, things that are not, or like you do like an indivisible operation. So you see, we have these as 7.6666667. So I think that's why they just program it that, okay, whenever you do a division, the output should always be as a floating number. When there's no remainder, it is 6.0. But when there's a remainder, it will give you the numbers of, just like you used to have it in mathematics. So basically, that's just it. And we have some other, we have some other operations. I think we already know division. You use your hyphen for subtraction, asterisk for multiplication, and forward / please. Forward / is different from backward /. This is backward / if you can see my screen well. So division is not backward /, it is forward /, the one that goes to your right. So take note of that. Some people mistake the two. So just take it is forward / that you use for your division. And we have exponent also. Exponent is just like raised to power. Whenever you want to do like a raised to power, let's say I want to do 4 raised to power 2, what's the answer? Let me call someone. There's someone bearing Joseph, right?
Yeah, that's Kabwe.
Yeah, okay, yeah. So 4 raised to power 2, what's the answer? Sorry. And sorry, please, if you don't like the way I'm calling out names, you can let me know. I just feel like just to make things interactive, please. That's why I'm having to I'm having to call out names. But if you're not okay with it, you can maybe tell Mr. Wilfred, and the next class I won't do it.
That's okay by me.
No, that's good with me.
Okay, all right. So, Mr. Joseph, please. 4 raised to power 2, what's going to be the answer?
I have no idea. I'll be lying to you.
Okay, so 4 raised to power 2 in mathematics is just like 4 times 2, that is 4 in
Oh, really?
2 places.
You
Yeah,
see,
4 raised to power 2 is 4 times 2. 4 raised to power 3 is 4 times 3 times 3. I mean, sorry, 4 raised to power 3 is 4 times 4 times 4.
yes, okay. Yeah, I was confused. Yes, that's what it is.
Yeah.
So 4 to the power of 2 is 16.
Is 16, right? Yeah, so the way you do that in Python, the way you ask Python to do that is say 4 and the raised to power, which is also called exponent, you use 2 asterisk.
That's 4 to the power 2. Okay.
So for that, this is just, it's saying 4 raised to power 2 now. And if I press enter, it's going to give me 16. You see that?
Oh,
Mind you, 4 with just 1 asterisk between 2 is doing multiplication. But when you have 2 asterisk, it is doing exponent. It is doing raised to power. Any confusion? Any doubts? Feel free, please. Don't be shy. Ask the question. There's no stupid question, please. So you can also do 8 raised to power 8. That's going to be like a huge number. I mean, 8 times 8. This is 8 times 8 this time around. 8 times 8 is 64. Or 8 raised to power 8. That's double asterisk, and it's going to give us, that very huge number, which is like 8 times 8 times 8 times 8 times 8, 8 in 8 places. Yeah. So that is what exponent is used for raised to power. And there's also one called the modulo. There's even one that I don't have here, but I mean, I will explain it to us. So modulo is basically just used to return a remainder. It's used to remain, when we divide 4 by 2, is there going to be any remainder? I mean, is it divisible? Is 4 divisible by 2? Let me ask that.
Yeah, there won't be any
4,
remainder.
yeah. Okay, so for people that are not mathematics inclined in a way, sorry, please. So I don't want to be using sorry all the time. For people that are not mathematically inclined, when we say something is divisible, that means it can a number can go in another number successfully without a remainder. Like for instance, now we can 4 divided by 2 will give us 2. That is, we can find 2 can go in 4 in 2 places. If I'm speaking the right, if I'm explaining the right way. So when we divide 4 by 2, there's no remainder. It goes successfully. But when we divide 5 by 2, we'll be fine. I mean, the answer is going to be 2 point something something. So that means there's a remainder. It doesn't really go successfully. So 5 is not divisible by 2. There's going to be a remainder. 4 is divisible by 2. There's not going to be a remainder. So the way modulo works is when you now do 5 modulo. So the symbol for modulo is the percentage sign that we use in what we call the percentage sign in writing is what Python recognizes as the modulo symbol. And when we write something like this, what the modulo is going to do for us is it's going to give us that remainder. After there has been successful division, or after it has divided with what can go, it's going to give you what the remainder. In this case, it's going to give us. Can someone tell me? Let me see if you've understood my explanation. Can someone tell me what the remainder is going to be now?
It will be
I
one.
said it's good. Sorry?
It will be one.
Will be 1. That's right. So let me now tell you why it is 1. We have 5. Let me do some annotates. Yeah. When we say 5 divided by 2, what we are saying is how many 2 can we get in 5? Uh,
2 times.
yeah, how many 2 can we get in 5? Now we are now saying modulo returns the remainder of returns the remainder. Remainder in the sense that, let's say we want to we are dividing 5 by 2. Let's count 5. 1, 2, 3, 4, 5. How many 5 divided by 2 is just saying how many 2 can we find in 5? This is one group of 2. This is another group of 2. What is left is 1. We cannot group them by we cannot group it by 2. So this has been successful. The unsuccessful part of it is what modulo returns. Do we all get that?
Yes, sir.
Yes.
Yeah. And this is very, very important, actually. This is very important, and it's one rule. Or I mean, this operation is, you see, I will give you an assignment probably on Thursday. And trust me, you will need this particular knowledge will help you. So it is all this building, all these little things that you put together to come up with a very sophisticated algorithm in the, a very sophisticated applications. Behind the scene, the WhatsApp that you use, the Instagram that you use, behind the scene, it is all these small logics that we put together that became those big apps. But because you are not going into software engineering, the focus of this program is not to make you someone that develop application. So you may not get to that point, but trust me, all these things that this little understanding is what will make they are the building blocks of the robust applications that you see out there. The reason why your bank is not able to deduct more than the amount you withdraw, they all lie in understanding of all these things. The reason why when you withdraw 1,000, it is 1,000 that is deducted from your account is because someone did not use multiplication instead of subtraction when they were programming your bank app. So you all understand why this is all important. So now I will give you a question. I will put something to us now. 40 modulo 9. What will be the answer? 40 modulo 9. What will be the answer?
Would it be 4?
What
4.
will be the Sorry?
4.
1? Okay.
4.
Sorry, I'm not able to like check our name, but we're saying 1, we're saying 4.
I think they said 4. 9 into 4.
4.
4. Again, let's do the 1, 2. Do I want to count 1 to 40? Okay, let's count 1 to 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Now, let's see how many 9 can go successfully. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is one block of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is sorry, I'm counting 9, right? This is another block of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is another block of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is another block of 9. we cannot count 9 again. So what's now the remainder? 1, 2, 3, 4, which is why we have 4. Do we all get the logic? I think this is the easiest I can go. Let me give us another. Let's work with a smaller number now. 5 modulo 1. 5 modulo 1. This one, I want to be able to track everybody's response. So can we all drop can we all drop it in the chats? Please drop your response in the chats. Okay. Okay. Don't, because someone else dropped something and drop it. Please take your time to think it through.
I really forgot. Where's my
okay.
Oh, hey. All right.
If you have to do it the manual way, the way I've been doing it, you can do it and correct yourself, or, you know. If we divide 5 by 1, what is going to be the remainder? Okay.
It's 5. So now it's 5, right?
Who's saying 5?
Reminder.
I say 5.
Is that Nadia?
Yes.
Why is it 5?
Because if you divide by 5 by 1, you still have 5.
This is not division.
I know, but that's the way I can understand.
No. This is so different from division.
That's what I was thinking too before, but when he explained with this, it helps a lot.
No, yeah, like
so
let's say in
modulo
division,
is not division. Modulo is meant to give you the remainder when you've done the. Now I'm saying 5 modulo 1, right? So the way to approach it, the way to find the solution is you count 5. The way you arrive at your solution, you still have to do some, division, this thing, but division is not like the final.
Yes.
It's not the final answer. 1, 2, 3, 4, 5. I'm saying, so now 5 modulo 1 is the same thing as count 5. How many group of the divisor, or I think 1 is the divisor in this case. I'm not sure if that's the right name to call it in mathematics. But what you are dividing with, how many group of it can you find in that? In this case, how many group of 1 can you find in 5?
5.
This is one group of 1, another group of 1, another group of 1, another group of 1, another group of 1. There's no group of 1 left, or there's nothing left, right?
Yep.
Yes.
So that is why it is 0.
Okay.
So the whatever is left is the
whatever
result.
is left is the result of your modulo.
Okay.
You see, now it is 0.
Got it now.
3 modulo 2.
1.
God bless you. Now I'm proud. You're making me proud. Yeah. So 2 modulo 2.
0.
Yeah, awesome. And let's do this. 40 modulo 5.
0.
Yeah, 0.
Why is it 0, Nadia?
Because okay, 40 module 5, right?
Yeah.
Because there is 5 times, like there is no remainder.
Yeah.
There is no remainder, exactly.
Yes.
5 times 20 give us 40 exactly.
Yeah.
Does that make sense? Yeah. So there's nothing like, there's no remainder, and we have 0. So do you understand that now?
Yes, I do.
Let me tell you one way, like an algorithm basically, where this understanding will really be helpful. Like in mathematics now, there's what we call the prime rule. Like you have prime numbers and you have sorry, you have prime number, even number, and odd number. What are odd numbers? Odd numbers are numbers that are not divisible by, that are only divisible by 1 and itself, right?
Yep.
And even numbers are numbers divisible by 2. I think if I'm right, yeah.
Yes.
Are you aware? Are you all aware of that?
Yes.
We have even numbers. So like the rule is that with even numbers, 2 can go in even numbers. And numbers that 2 cannot go in, they are called odd numbers. So if you want to program that, I haven't thought of any other way. And the only approach is to use this modulo. And you know that when you divide it, when you are given the when you're asked to write a program that identifies even or odd, the rule is that you already know the rule in mathematics that when 2 is divided, when 2 can go in that number, it is even, which is something as saying when the modulo is 0, when you divide that number by 2 and the modulo is 0, it is an even number. When the modulo is not 0, it is not an even number. It's definitely going to be an odd number. You see where that applies?
Yes.
So that's one way you can apply it. And a whole lot of, I've written a couple of algorithms where I've used this modulo. And so, this is not like just the only way these things are applied. This is not where they are not just relevant in calculations alone. You use them they're like building blocks to even more larger programs. And there's another one that I did not include, and I think it is the floor operation. Yeah, I think that's what they call it, the floor operation. So it's just like you use double forward slash. Double forward slash. So, and the way that one works like it's like an opposite of modulo. Double forward slash. So it also does let me just demonstrate and you see what I'm saying. 20, let's just call it floor. I think floor is what they call it. When you have 2 forward slash, 1 forward slash will do a division. 2 forward slash will do what we call a floor operation. So you can call it a floor operator. Double forward slash, a floor operator. And what this one is going to do for you is modulo returns the remainder, right? This one will always return the whole number part of your division. So now, 20 divided, let's first start with modulo. 20 modulo 3 is going to give us, what's going to be the answer? Mr. Joseph.
Yes, sir.
Yeah, 20 modulo 3, what's going to be the answer?
Is that 6?
20 modulo 3.
3, 6, 9, 12, 15. 2.
No.
2 is left.
Is that from Mr. Joseph?
Yes. We said the remainder, right? So
Yeah,
6 times
20
3 is 18. So 6 times 3 equals to 18. So the remainder is 2, which is
2.
2,
Awesome.
right?
Yes, 2 is the correct answer. I'm kind of proud now. That means I'm doing a good job. So then then I said floor operator does the opposite. In this case, it is not going to give you the remainder. It will give you the number of times your divisor successfully goes in your I've forgotten the name we called the other. It is dividend and divisor also. But basically, it will give you the whole the number of times your denominator can go in your numerator. Like in this case, now let me do 20 floor 3. So this one is going to give us the whole number, the number of times 3 can go in 20, which is 6. And you see 6, right?
Nice.
So if you have to write another logic that requires you to get just the part, the whole number part of things, then that's when you use the floor operator. If I do 4 floor 2, what's going to be the answer? Let me call there's one name. Please, I just want to make sure everybody is following. I haven't called Alexandra since. Are you with us, Mr. Alexander?
Yes, I'm here.
Oh, all right. So please, have you been following us?
Yes, I've been following.
Okay, all right. So what do you think is going to be the output for this for floor 2?
Then 4 divided by 2.
Double forward slash is not doing division, like I said. It's another operator. It's called the floor operator. And what it does is it returns the whole number part of a division. So the way you go about arriving at the solution of it is to first do your division, and the whole number part of your answer when you do the division is what the floor is going to return to you. So by that explanation now, if I say for floor 2, what do you think the output is going to be?
2.
Sorry, sir.
2.
Yes, you're right. You're right. It's going to be 2. Regardless of whether there's a remainder or no remainder, the floor operator will always just give you the whole number part of your division. If I do 4 divided by 2, the answer is going to be 2.0, right? The answer is going to be 2.0. So what the floor operator does is to give you the left part of that decimal point. If I do 30 divided by, let's say 30 divided by 4, the answer is 7.5, right? If I do if I do 30 floor 4, it's going to give me the whole number part of it, which is 7. Do you get that?
Right.
Any question?
No.
So that's very clear. If you want to do a floor operator, you know what symbol to use. If you want to do a division, you know what symbol to use. Modulo, you know what to use, and you know how they work. Awesome. So let me quickly clean this up. Oh, okay. I think we use like an hour, 30 minutes. So I feel like it's late already over there. It's currently 2:44 a.m. Yeah. So, but then I think we can continue in our next class. I don't want to like bore you. So you can just, what we've done today, you can just try and even do more practices with print statements, print a lot of things, try different, try out some, if you're curious about anything, try it out, make mistakes. Just see how the print statement alone works and try out. And now, as part of our exercise, I will give you to, do on your own. All these operations that I've done in the cell, in these things that I've written in Python shell, now put them in a script, put them in a file, write them in a file, right? Like this one, like you can just do print the modulo, right? You can do 40 modulo 3. Put them in this thing and try to print them out, see the outputs, and just play around with them. So that would be like the exercise for this. And on Thursday, we're meeting again on Thursday, and we'll continue from here. So I believe I've laid a very solid foundation at least to understand why you need to learn Python, and so we'll build from there. And next week we'll be able to move faster than this.